Welcome in, everyone. How's everyone doing today? Happy New Year! I okay. The plan was to be on stream for the New Year. I slept a little longer than I thought, so stream was late. Sorry about that. Um, but yeah, Happy New Year. I hope everyone's New Year has been good. I guess if you've been awake for the New Year. Um, I think everyone has New Year now. Pretty sure West Coast is like one of the last to get it, at least. Anyways, we we're gonna be coding simulations some more. Specifically, the evolution simulator we started um, 2 days ago, last stream. So yeah. Uh, Anything else? No. Yeah. Let's just get into it. May the wellerman come. We got sugar and tea and rum. One day when the tonguing is done, we'll take our leave and go. Alright, that should at least be outside. That's fine. And then we can just make it its own separate thing. Back, you get to be part of this. New Python file. Chromosome. Stat, not JS. Yeah, dot py. Main. Yoink these. every night we roll. Through the phantoms here we roam. Met their fate in the depths of Jones's, and the could congregate. Storm he raved their galleon, now who raises in their soul. My hellish purpose, reaping vengeance from below. Heave ho, on this eerie night we row, where the dead rise to tell the tale of old Keel Hall Joe. Through the phantoms here we roam. His eyes are hollow, and his breath a chilling mist. His frame torn asunder with iron shackles on his wrist. They were the cutlass, sharpened on the keel's teeth. So ship that condemned him and his crew to drink the sea. Heave ho, on this eerie night we row, where the dead rise to tell the tale of old Keel Hall Joe. Through the phantoms here we row. Oh, beware of Keel Hall Joe. Oh shit, yep, give me a second. Sorry about that. Wait, sorry, I haven't been talking that much. I think the caffeine still... the caffeine is
Hello, motherfucker.
doing stuff in the system. Hi, Ghost.
Hello.
Oh. Well, that's not supposed to do that.
Hello.
Why is everything broken? Oh,
Hello.
oops. Save. What the fuck?
Hello.
Why are there two? What the fuck?
Hello. Hello.
What? I broke something. Hi, Ghost.
Hello.
I don't even know what the daily anchor redeem was supposed to be. What the hell?
Hello.
Well, hi, Ghost. Okay, you know
Hello.
what? At least one of the shoutouts worked. We'll take that. Yeah, I think I probably added that redeem
Hello.
for something. Oh my god. How many are there? So many. Okay, it's done.
Hello.
Nope, never mind. Yeah, I think I added it for some redeem that I wanted to do.
Hello.
But I don't know what, because...
Hello. Hello.
I don't... well... See, it all works until it doesn't.
Hello. Hello. Hello.
I think it was something that broke in StreamerBot, but I don't know why.
Hello.
Yeah, no. Well, how's it going, Ghost?
Hello.
What the Okay, well that's just gonna keep going for a while.
Hello.
I'm working on better sound redeems, not using sound alerts.
Hello.
Because, I mean, one, sound alerts is annoying, and two, I don't like that it posts in chat and stuff. So I'm working on just making
Hello.
everything in StreamerBot.
Hello. Hello.
Sea salt in her blood.
Hello.
Born on the high sea water, rose like a rising flood. Her skin tough as stone with the fire. He's the lone
Hello.
wolf water road.
Hello.
You're doing good? Me?
Hello.
I'm doing alright. I don't think so either.
Hello.
Okay.
Hello.
There. That should be it. I told it to skip all the entire queue. You done now? Okay, it's done now. So this is why I'm moving away from sound alerts. But yeah, also like when I make the system, you can like search for the specific sound that you want for each alert. Like right now I have like for hello, there's hello there, and then the hello motherfucker. That one. So you can search for the one that you want by like keyword if you want. Or not. And then it'll just pick a random one. The deep sea taken, Calypso sails. She sails alone. Jason Calypso sails. She sails alone. No, we don't need this. So we have that and that. So then we have a chromosome ID. We have gene types. We have... yeah. And then that's all fine. I was born under the trigger. My old man was a sinner. My mom told me to run, son, till he gets the water. I ran in with vinegar. Row your boat, row across the sea. Heave her up your skirt, just a head into the deep. Oh, row, row, row your boat, row until you bleed. Hoist the sail and fly until the tide is with the dream. Row, row, refugee from Bonnie land, row until you don't see land. Row, row, string on, row, oh, 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 row. Me, man, he's a silly. Like the row your boat, row across the sea. Heave her up your scurvy skin, turning up the deep. So row, row, row your boat, row until you bleed. Hoist the sail, you fast as well, the eye eye for me. Row, row. You from zone and zen, row until you don't see land. Row, row. Hi, Faye. How's it going? I want to do this. Faye, you're good. Nice, nice. That's good to hear. I guess New Year's was a while ago for you now. It's finally New Year's and you have to do everything you want to do religious-wise? Well, that's good to hear. More caffeine. Oh, 2 hours only. Oh. Okay. Right, right. Two-Phase. What the hell? Oh, because it's entirely different. Can I ask what I'm making? Yeah, so the current mini project is a bunch of like different types of simulations. So last stream we made a sand pile simulation where it'll stack sand up in the middle and then the sand topples, and so it's doing that. It's a lot faster. Come on. But yeah, so that's what this does. And so then now we're making evolution simulation. At least we're trying to. So any would I do it this way when I can do it like this way instead? Self.parent equals get some. Type equals this. Self types. Nah, oh. Well, okay, I wish you luck. Thank you. Okay. Thank you for the save, Redeem. Class method, not self, so this will be CLS. CLS. Then we just have types. ID equals none. Chromosome ID is none. Return type of types. Else returns CLS dot pool of chromosome ID. Yeah, that should work better. So then there should only ever be one of each item. The captain's daughter, sea salt in her blood, thrown in the high sea water, rose like a rising flood, her skin tough as stone, the fire in her bone, only the known. It's replicate, and this will be a constant up here. And the night is dear, in the chest of vengeance. Where the children hide. That'll work better. Self but this can be none. Float. ad in just a couple of seconds. Thank you to everyone who sticks through the ad. Help support the channel. And what? Fuck, I'm so sleeping a little bit more than I normally do is probably not a great idea. But, whatever. Yeah, thank you to everyone who sticks through the ads. I really appreciate it, and it helps support the channel. Any money from ads goes straight back into improving the channel and stuff. Right, it tells me when ads are about to start, and then once it says ads are gonna start, it takes a couple of seconds. I don't know, I've seen it take up to like a minute for it to actually start. But there we go, there's ads. It happens eventually, but it's not always quite on time. From a bird's eye view. Actually, we don't, because this will. This is a method you should override, but you don't have to, because it'll already implement some of the logic. You don't see the ads? Yeah, well, I don't know, some people don't seem to get them. They just don't happen. It's weird, but Twitch is weird. So, I don't know exactly how they do it. And like some platforms, and like some, I would assume it just has to be how well you're connected to Twitch. Oh yeah, I mean, like if you have Turbo, then you definitely won't see ads. Thank you to everyone who stuck through the ads. Like I said, help support the channel. All money from ads and from like other stuff on Twitch goes just right back into Twitch and making the stream better. I don't even. This is, I think this should be chance. I forgot, how many digits does a float have? I don't need that, I don't need that. I don't need this one necessarily. I'll still keep that open. And these. Okay. Random dot. I didn't. Thousand. We'll just add that right here. Disk dot pi. This works, I think. Import random. Random and digits. And int. Yeah, and yeah, that's an okay name. Random and digits. What the fuck? Oh. I mean, yeah. Float. Is it like this? No, it's the other way. Float, yes, float. Return random dot rand range 0, 10, n. There we go. Divided by 10 to the n. Yes. Is it dot dot? I think it's dot dot. Yes? Okay, that's fine then. Okay, so question. Air fryer snacks for breakfast or bread with eggs? I mean, air fryer snacks is always a good option. But, I don't know, bread with eggs is also good. Oh no, I'd go with bread with eggs. It's usually a little bit more filling. Miss dot random n digits. Oh, whoops, nope. Is it just import misc? No, how the fuck do we... Yeah, if we aren't treating it as, from evolution? Okay, that one's fine. Oh, right. Python doesn't do stuff like that. Well, I mean, how many digits can a float have? Okay, we just gonna... Oh, okay. So it's a double on the inside. Probably like 5 digits is fine. Oh yeah, how to do imports from outside the current folder. To import files outside the current on package. Because I think you can... That's not what I asked for. No, shut up. Copy this. There we go. What do you have? Okay. Okay. I think we'll use import lib. That looks like the cleanest. Okay. Yeah. spec than we... Okay. Okay. Import. Import. Actually, who gives a shit? It's fine. Just from import misc. I know we're not inside of a package. It's fine. You still work. This one. Yeah. It's probably a technically better way to do it, but I don't care. To the n. N. I can type. Def get min digits return. Is that right? No, this is just one. Nope, not mutation chance. Mutation prick. Not max. It's min. Actually, get min and digits and this doesn't work for things above 1 though. Actually, that'll work just fine, but we start at 1. That's 1. Okay, and this should work. You can have a 0 chance of mutation. You can have it really low, but it can be 0. So mutation chance has to be between 0 and 1. So if it's greater than or equal to 1, then we give it the max, and if it's less than or equal to 1, we give it the minimum, while still being above 0. Oh, actually, if trait abc dot abc. Oh wait, class. Sorry. Well, that should be under its own separate thing. Import traits. Jackal buff. No, that'll be under genes. Not directory. It's a new Python file. Traits.py. Import decimal. And then we need to import ABC. Import ABC. ABC.abc. Def. Wait, no, there isn't an init file. That's why it's a problem. And this is just to make everything like a nice, clean. Oh, well, that's not what I want to do. Def, this is an at abc.abstract method. Def replicate. Chance float. Yep, like that. Why? This is in the traits class. You just don't, it's fine. Def, not mutate. I'm not doing that on purpose, it's just a replicate. What else? Like this time to defrost the bread. Defrost? Sorry, I didn't see that earlier. Keep your bread in the freezer? What else? And I think that's it. It's just we need to replicate. Float. Float. Int. Uh-huh. If n equals 0, return 0. No, that doesn't make an int. That makes a float. Is this right? Yes. I should probably move this to a separate thing. Def get max and digits int int term get max and digits int and minus -1 if n is less than 0, else 1. Def get max get min and digits int and int term if n equals 0. Alright, this. Yeah, that'll just do that. Will this just do that though? No, but it'll be fine. It still returns an invalid value. Return. Should we be more explicit with it? Yeah. If n equals 0, return none. None. Yeah, this will be better. It's more clear if we return none instead of just returning a value that's technically not right. Turn none. None. Turn none. Turn none. Turn random dot rand range like that. Wait, no. This is just What the hell am I doing? To the n minus 1. There we go. Because the minimum integer above 0 is 1 for any range. These are float. Min. And min digits. Float. Actually, you won't even need this. I don't think we need anything else, so just class small. It's like, and then we'll do this, but def, this, it's not float, it's the decimal. Import this from decimal, import decimal. There we go. That should return decimal. Wait, do we need the decimal here? I don't. Do we? I don't know. Yeah, whatever, you're fine. We'll split the float up like this. Closely. I assume because it has a to float converter, which is why it's okay with it either being a decimal or a float. I assume. Trait. Yeah. Self. Float. Decimal. Tools. Sing where I step Still hanging in the balance, not the life I want to live. I want to take it all. Do we even need this? It felt really smart when I started doing it, and then I was like, is this actually necessary? No. I mean, good rule of thumb, don't never delete code, because it might be important. You might want to use it later, but I think we just leave it like this. I think whatever 16 digits is enough precision. Mutation chance. That's a trait that every gene will have. What's another trait that every gene will have? Look up in the window. The window. Bring me down. Watch me levitate. Mutation. So how much do we want something to mutate? Anytime the mutation does happen. Like, I don't know, like 1% is a good starting point. We can change that later. Mutation amount equals 0.1. Up in the window. In the window. Watch me levitate. Self. Self dot chance equals that mutation chance. Up in the window. Dot values. when I start to see I am a perfect 10. Equals -1. Else self.gene ID equals self.pool dot keys. Okay, yeah, so that'll work. Because for the gene pool, it's just an example. It's not the actually same gene. Upside down. Whereas with chromosomes, like each chromosome is identical, like it's the same chromosome that you or the same chromosome type. So it's a slightly different like framework that we're building it around. Oh hi, Idealist. Shadow, I'm about to go to bed, but I want to stop by and say hi. Happy New Year. It's like 5 a.m. here, so I asked you would chill and stay. Yeah, I mean, I appreciate you hopping in and saying hi, but go to bed. That is important. Do as I say and not as I do. I think some of the framework changed, which is why everything's broken now, so I have to fix some stuff in StreamerBot. On top of adding all the sounds and everything, I need to fix the shout out may or may not be working. I have to check. A couple other things. So there might be a stream tomorrow. That's not really a stream. It's just me testing stuff. I mean, if you see that, you can always hop in, but I won't have the mic on. Maybe like tomorrow or in a couple days, whenever I get to it. If we're less than this, then we did the mutating. Random n digits float. Mutation precision. Right, because we need something that also does the same, that's on the same level of precision, otherwise the precision is pointless. Int Oh, uniform. Oh yeah, I forgot about uniform. I forgot that was a thing you could do. Random, nope, not insert. Random dot uniform. 1 minus mutation amount, 1 plus mutation amount. Return gene. Oh, because it's an abstract class. Wait, then how do you... Uh-oh. That's not good. Hi. Okay. Still connected to the internet. It's just OBS. Well, sorry about that. I don't know what happened. But that does happen sometimes. To instantiate No, but you need to call super. Abstract method non-ABC. I think we then don't use this for this, because I do need to instantiate one. So then it's not this. I guess it just does nothing then. I would much rather enforce it. Well. Well, I guess it's not entirely necessary. That actually does anything. Copy. No, if it is none. Well, self.gnd is just gnd. We trust that you know what you're doing and that you don't fuck it up. I think. Return Gene. Okay, well, self.mutation chance and self.gnd. Return self.copy. If we don't mutate, then that's fine. Okay. So that makes new gene. I think that's everything. Should be everything. Okay, so we have gene base, which defines just your base behavior for genes. And then I guess we'll make gene I think we can do it this way. I think we can do it as one, but we might not be able to because of circular imports. Let me build that up. So, our circular import. It says pretty much everything in the name, but it's when I say, hey, I want class 1 from file 1. Alright. M1, module 1. Mod 1. Yeah, M1. Right? I say, hey, I want class 1 from N1, and I am in M2. So M2 says, hey, I want that. But then N1 says, I want class 2 from M2. Circle. And this breaks everything, because obviously they're just going to keep requesting each other. And this is bad. So the best way to fix this is using, one, you can use import lib to import exclusively one class and ignore the entire rest of M2, which includes all of its imports. I'm pretty sure that also means that you include all of the imports that class 2 uses, which means you need to import those yourself manually. Or you put it in a bunch of separate files. If M1 requests M2, then we say, well, I mean, this class 1 doesn't use M2, which is why I can use it M2. This class 1 only uses whatever. This class 1 is a standalone. It doesn't use anything. So I say, well, class 1 will put you in M3. And now I can request this, fine. Because M3 doesn't want M2. So there's no circle anymore. M3 gives you class 1. Class 1 goes into M2. And M2 gives us class 2. And then everything is fine. So that's why you have to be a little bit careful where you put all of the different classes, because otherwise you get circles, and circles are bad. Hello. Wait, is it this? Not that. This. Hopefully that makes sense. Import from gene base, import gene class chromosome gene. This start mix. Right, so the interesting thing about chromosomes, I don't know if everyone knows this, so we're gonna explain it real quick. You have your chromosome here, right? Sometimes, or every time, when your body makes new chromosomes from it for the purpose of reproduction, right, this is your first pair of, let's say, I don't know, C chromosome, and this is your second pair of the C chromosome. So this is C1, C1, and this is C2. So what your body says is, great, we'll just take, because this is to have just enough volatility that you get a wide variety of different traits and behaviors. And that's important because the bigger the variety of traits, the more that people are, or the more natural selection can happen. So the more you can get better and more efficient traits. You can only do that if you do a lot of, if you have, not a lot, but if you have a decent amount of volatility. So you could just rely on mutations themselves, And, you know, obviously, right, your partner has their own C1 and C2. So you could say, well, I'm going to take my C1, they're going to take their C2, and then that makes a new person. Or you can add even more volatility by saying, great, this C2, we're just going to grab this, and we're going to put it here. We're going to replace this section of C1 with that same section of C2. And then we're going to replace this section of C1 with this section of C2. It takes a chunk of C1 and replaces it with a chunk of C2. They swap. So this is actually both. It goes back and forth. They swap pieces. And this just means that there's more variety. Because even each chromosome is not quite the same. But they should all be. But even though we do this, this C1 chromosome should still remain a C-type chromosome, because it has all the same gene types. Even if the actual behavior of the gene is slightly different, it's the same gene type. Let's say this encodes for eyes. Oh my fucking god. Eyes. Right? This also encodes for eyes. Whatever. Eyes. So when this goes here, it still encodes for eyes. It's just that your eyes might be different. I don't know. Maybe you have brown eyes or something. So even when they swap, it should still stay a C gene. And that is what I'm trying to accomplish. What I'm trying to get it to do. Even if we do the swap thing, it should still remain chromosome gene. Chromosome behavior gene. It should still remain with the same behavior. Or it should still remain the same. Like the same type of chromosome, which is why we need to then include a chromosome behavior gene, which will define how each specific chromosome, what things get swapped. Mix proportion mix start. And no, mix proportion is a float. Float none equals none. Float none equals none. Did I do that? Right? Float none equals none, yeah. So if you make one without any start, without any like variables, it just randomizes everything. This is not a float, this is an integer. Well, no, it should be a float. Mix start. Oh, right, and then a mutation chance. Chance. Floats. None Nope, not gene name. We don't have names because I'm not generating those. Gene ID. Else. Prop rec equals. Keep this 5. Kids screaming in their cradles, profanities. But that's alright. Misc dot random float mix prop right rec. Yeah, no, mix start should be a proportion rather than an integer. My sword, he will tear your city down. Ole, ole, Lord. Ole, 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 O Lord. He will tear your city down. Ole, ole, Lord. Then will come the Lord with his word. He will slay you with his tongue. Ole, ole, Lord. Ole, 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 O Lord. He will slay you with his tongue. Ole, ole, Lord. float. Yeah, I know it wants range, but I can't name it range because range is a thing already. That would be dumb. So I guess we just leave it like this. It's fine. 0.2 though. The range is 0.2, so we're getting only like a certain chunk of these digits. Yeah, that should work. Wait, less than or equal to 0. No, self dot mixed proportion equals misc get min digits floats. It doesn't have one of those. If greater than or equal to 1. Self dot mix proportion equals misc dot get max n digits floats times 0.2 mix prop. We're gonna leave these all as consonants or constants, so it makes it easier to change them in the future. Because then I have to change a single number instead of finding everywhere that this happens. It's a little long, it's a little messy, but in the long run this is much better. Okay, so that's for one of the things. What's the other thing? The other thing is mix start portion start. Wait, no, it's an no, right? No, correct. Equals 5 is fine. No, the range is just 1 minus that one. proportion. Else. What the hell? This dot random and digits float start prec 1 minus behavior gene dot mix prop range. If dot get min and digits float. That's chromosome behavior gene makes start. This is all mixed start. I don't like it when the code starts looking a lot like blocks, but it is definitely it's definitely like better to do it this way. Doesn't make it any less annoying though. 1 minus. Wait, what the fuck? Why am I doing this self? Okay, well then make it a little bit smaller. It's not like. I guess it's technically like bad to use like self like this, because it isn't technically a member. I like the difference is like this is at the top, which means that this belongs to the entire class. So every object of this class will have the same numbers here. So if I change something in one object, it will change it for every object. So normally I would say it's probably bad to use self. But also no one else is going to use this code, so I couldn't care less. I think that's a lot of the philosophy when it comes to these. It's like, well, is it technically not ideal? Yes. But no one else is going to have to maintain this or use this, so it doesn't matter how clear it is. That's why I don't do documentation for any of these, because it just doesn't matter. Oh, right. No. Wait, what the hell? Yeah, okay, it's fine. The super of this should work. Super.init is just a more explicit way of doing it. I think this still works though. Yeah. Alright, you're just confused because of that. Oh my god, that's why. Super. Apparently you can't do that. I didn't know that. 1 minus self dot max digits float, make start precision, and then we multiply it by self.make start proportion. mixed proportion. Mixed proportion. Mixed proportion, that's why. Okay, yeah. Because it has to be less than how much of the, how much of the thing we're using for mixing, because we're gonna mix whatever, I don't know, 0.5%, 0.05%. We can't start later than that because then there physically isn't enough stuff to mix. And yeah, we're just gonna mix one chunk. You could probably make this like a list, but sounds too complicated. This is fine. Just one mix. Express. Oh yeah, it does nothing with creatures, so we don't even need to do that. And self dot mix proportion equals other dot mix proportion, and self dot mix start proportion equals proportion. All of the variables need to be the same. For equals gene types, that's a class method. We don't even need to do anything with that. Copy. Def. Copy self, return self mutation chance, self dot mix proportion, self dot mix start proportion, and gene ID. All of it. It's a copy. And then replicate. If basically for each trait we're checking whether this is a thing. What? Oh, gene types. This is going to be gene. Do we need to make some of the behavior again? Yes, but it's fine. New mutation equals none. Wait, what is it called? It is mutation chance. New mutation chance. Mutation chance. New mixed proportion. New mixed start proportion. Mixed up random and digits float mutation. Yeah, I should probably do it this way. New mutation chance, self-dot mutation chance. New mutation equals wait, no. If new mutation chance self-dot mutation chance return chance like that. Return gene. It does not equal patient chance. Random and digits float. Less than self-dot mutation chance. New mutation chance equals self-dot mutation chance times that random. If mask dot, and we just do this again. New mix proportion mix proportion times mix dot start proportion times random dot uniform. If new mutation chance or new mix proportion or new mix start proportion. So if the mutation chance is not the same, if the mix proportion is not the same, if the mix start proportion is not the same, then we return a new one. Otherwise, we just copy it. New mutation chance, new mix nope. Not gene. Chromosome behavior gene. Else, turn self dot copy. Subclass? Huh? Okay. That's a thing that I won't feel like getting into. There's gotta be a better way than rewriting all of this logic every time. I think what we'll do, def replicate, it's replicate this. Return new mutation chance self dot. Two separate lists. Oh yeah, and then we just change the replicate inner, and then we can call super replicate inner. And okay, this works. This works. This is smart. New properties. Old properties equals self dot replicate inner. New properties not equal to old properties. New properties. And we just have to trust that this is in order. Or we could do it using a dictionary. That would actually work. Mutation chance. Mutation chance. But then it's using keyword arguments. So, right, mutation chance. Yes, mutation chance. And then it's replicate inner. New properties, properties equals super replicate inner. If messed up random and digits float. New mixed proportion. Old properties and mixed proportion equals self dot mixed proportion. Self dot mixed proportion. Old properties of mixed start proportion. Self dot mixed start proportion. Yes, yes. Is that logic checkout? It should. Return new properties, old properties. And that way the replicate logic is or the replicate itself is one call, but then this inner can build on top of the next, or right, this one just calls super and then adds to it. And then so if anything subclasses this one, then it'll call super, and this one will call it super. So you get that same kind of like building blocks kind of effect. Because I would much rather do that than rewrite all the code. Because one, if I change the logic in one place, I have to change it everywhere. If I like rewrite the code. Whereas if I do this, then I just change it in one place and it changes everywhere by itself because I use that code everywhere. So this should hopefully make it easier. actually might. Okay. Mutate def tate and float. Chance. Anything else? Mount. Mount. Also a float. And num is just a number. Some number. If get. Oh, chance. Chance precision get random n digits float like right above you? What the hell? Oh, random n digits float. It's not get. Control C. Random n digits float. Spec less than chance. Return times random n digits. How do we do it here? It's random.uniform. Oops. Random.uniform. 1 minus amount, 1 plus amount. Else return num. Dot mutate num self-mutation chance. What's next? Mutation prep amount is mutation amount, and then our number is self.mutation chance. That should make things a little bit more concise, even, because it's all the same thing anyways. Self. Mutate num. This is all the same. Self dot mixed proportion. Mix start proportion, and then this doesn't do anything anymore. Oh, hi Notorian. Thank you for the lurk. Hold tight, get me close to collide. Hold tight. What else do we need to do? We need to, I guess there's replicate. Now there's copy self, which is chromosome self.genes, and there's replicate exact, which is turn chromosome gene dot replicate for gene and self.genes. You can point to the one, right? Yeah, you can. Okay, perfect. From genes dot gene types import chromosome behavior gene. That's important. If not any instance genes gene behavior gene for gene and genes raise value error 1 chromosome gene needs to be of type chromosome behavior gene. Yeah, because we do need to get behavior from somewhere. I could do like base logic, but it makes more sense if there needs to be some kind of chromosome behavior gene in the chromosome. So we'll do that. So replicate exact just takes this chromosome and replicates each of its genes, so then they have the chance to mutate, but there's no mixing. So then the other one will be def replicate mix self other if other dot mixed chromosomes must be of the same type. Yeah, you can't mix chromosomes of different types because then you get weird behavior and that would be bad. Yeah, I think that's also why it makes sense to have this be... No. Oh. Great. Gene types. For I and range len gene types. Len self dot gene types equal to len gene types and because short circuit, this should happen before this so we don't get any errors. And then this one, it respects order, which is important. Because if you do change the order, it is a different chromosome. It's not the same. Mostly because you can't do the mixing. The mixing will just break. These chromosomes must be of the same type. And yeah, replicate mix will modify both, which is why this is important to, well, I mean, it's still important because otherwise they aren't the same. Rename chromosome type. Start and behavior equals gene dot is instance gene chromosome behavior gene equals gene. So it only uses the first behavior gene. So if there are multiple, they will get passed on, but they aren't used. They're dormant or something. Should we do it this way or should we use randomness? Because we could do randomness. Yeah, why the fuck not? This behavior genes. Behavior genes dot append gene. Behavior gene equals dot choice behavior genes random equals behavior gene dot make start proportion self.genes. Mix amount equals and or mix and equals start, and then we will convert them to ints. Equals mix start plus behavior gene dot mix proportion times len self.genes. And for this reason, mix start and equals int mix start. Oh, wait, no. And self.genes -1. Oh, wait, no, you are allowed actually to be 0. If you're less than 0, that's a problem. Self.genes mix start and -1. This default behavior should keep it safe. If mix end self.genes mix in, yeah. Self.genes mix start and mix end. Another mix genes for I in range. Start end mix end in. No, self.genes of I equals other mixed genes. Genes of I equals my mixed genes of I. Or self equals self dot replicate exact. Alright, self genes. Other equals other dot replicate. Other. So this self, ret other. Actually, this doesn't matter. I think we just do it like this way, so then each one we'll call on the other one, but it only returns the mixed version of itself. And then because we use replicate exact, mutate self for gene dot replicate genes of I, other mixed genes of I. Yeah, no, we need the ret self, but it's just ret self wouldn't come. We'll still do this. Genome mutate, that'll still happen. It's just ret self should be up here. Sat upon the heath, sure phantom tales from tales my mom told me. A ghostly galleon filled with gold, she sails alone. No crew nor captain's guiding hand can tame the one the sailors call the shadow. And horizon mad, thinking her wasted sails my course was set. My colors have inspired me by dark eyed. The way prepared was not to lead it. Call the shadow. None can tame the one the sailors call the shadow. Ret self touchings. The drown me just first by and heave ho. The first light shall give us up. Who tried it in the shadow. None can tame the one the sailors call the shadow. A mighty tempest blew. The banshee cried, turn back, but our resolve was true. I pointed bow ahead and shouted, we'll break through. The jaws of hell can hold us back. There's nothing that can keep us from the shadow. Winds were stronger still. The ocean raged against us, tried to break our will. The sirens in the water, thirsty for the kill. The vessel peered to and fro to tear us to the one they call the shadow. None can keep us from the one they call the shadow. Lean left, hard right. Just first bite, heave ho, till first light shall give sight to all who try to tame the shadow. None can tame the one the sailors call the shadow. As when they strip the sky, A lightning grew a ship beyond the tempest side. A chill ran through me spine as legend came alive. Fast I cried all hands as we prepare to take the one they call the shadow. What? Nope. Self dot. Mutation chance. Mutation track. Mutation amount. Self dot. Max proportion. Amount. None with an N, else mutation amount. Sorry about that. If amount of amount is none, else mutation amount. So the ship that put to sea, name of the ship was a really OT. Down. Oh, that's not good. Women come to bring us sugar and tea and rum. When the tongue is done, I'll leave and go. 2 weeks from shore. Alright, call all hands and shore. We take that whale in tow. Soon may the wellerman come to bring us sugar and tea and rum. When the tongue is done, yeah, we'll build that later. Give me a sec. Self dot mix start proportion equals mist dot mutate num self dot mutation chance mutation pack amount if amount is not none else mutation amount self dot mix proportion. Didn't kind was not hungry. He belonged to the whaleman who that ship into mutate amount. Take a leave and go. Mutation chance. Mutation pack. Mutation amount. Float. None equals none. Then we'll take our leaves and go. The fight's still on. Line's not cut and the whale's not gone. The wellerman makes his regular call to encourage the captain, crew, and all. Soon may the wellerman come. None will take our leave and go. Soon may the wellerman come to bring us sugar and tea and rum. And when the tonguing is done, we'll take our leave and go. I mean, that looks alright, maybe? And like, the problem with such a large scale project is that it's hard to figure out exactly like what exactly like the plan is in the end. So we're gonna make a plan. Yes, yes, yes. Evolution simulator plan. Evolution simulator plan. I mean, we have a couple things, but yeah, it's a hard bit. Let's see. We have a gene like base. We have a chromosome base. I guess like after that is building like creatures and stuff. Fall into oblivion. Forget about the world we're living in. Okay, this is a lot more complex than like the base stuff. I guess should we make a base one? Like where it's just a couple of numbers? Might make it easier to do all of the more complex stuff. Okay. We're gonna yoink these. Directory complex. See if we can make a simpler one first. That should be easier in theory. You had the door. You had the door. Yeah. Oh, you had it all. To oblivion. Let's see, simple. What do we? I suppose we'll just call it. So we have a creature dot py, and these. It's a very simple creature. Import random. I don't need that. Anything else? Class creature. No. I don't know why you do this. I don't know why. Why though? Because all objects are already subclasses. It's implicit. Why do you need to do that? So def and self. We got mute chance, mute amount. Hunger. Will be like a Hellcat. So very simple. I think that's about it. New chance. This is a float. Amount. This is also a float. Oops. Float. No, not float int none equals none. Okay, we'll do it like this. Random. If amount random. Strength equals like 10 or something. Min strength equals. Sure, we'll do it like that. And int if self dot is greater than or equal to max strength. Self dot strength equals max strength if elif self dot strength self dot strength. That's what I meant. Self dot food rec equals random 2 times random dot random. No, there is no min strength. It's just 0. What the less than So 0. Equals 1. It has to be 1, not 0. Okay. Self other turn creature, and then we'll just open it up like, not like that, like this. Import math mean suck. Maths dot oh, what the fuck? Okay. Come on, I guess I don't need math. Okay, I don't need the math module. Equals self dot mute times no plus these trans is all divided by 2. Amount, new strength. Self dot weight equals random dot random 0 point random dot uniform 0.35. Upper weight float none. Chance. this is random dot uniform 0.35 0.65 wrapper weight is less than or equal to 0. Wrapper weight equals this should be an int, because then we can do random randint 1 max wrapper rate. Zero greater than or equal to. Oh, we should do it the other way, because that's the way we did it before. So this goes here, max wrapper weight, subset wrapper weight equals 1 equals max wrapper weight. Random. Wrapper weight times rand. Times random dot random. Then we do times other dot wrapper, not that. Wrapper weight times random dot random. Creature. Wait, creature doesn't exist yet, so we have to creature in quotations. Yeah, okay. So now it knows like what type it is, and that's good. So this unit chance unit mount weight. Nope, same thing. Another random. My strength weight. It has nothing to do with strength. It's a different number each time. But we do need to know. This is the only one that makes sense. Other mute chance weight. No, it has nothing to do with that. Stop it. The wrapper weight. There we go. Other mute chance weight times my mute chance weight. my mute amount weight. My mute. Not my other. Other. My strength weight. And this other strength weight. Mu repper weight equals self dot times my repper weight plus other dot repper weight times other repper weight. And now we just add them together. Mute chance weight. Mute amount. This is my strength weight. This is repper. Yeah. Yeah, that works. We lose. One. Int none max kids. I'm gonna set that to 5. It's good enough. Equals none. Equals none. Num kids. If self.kids is greater than or equal to max kids, we left to less than or equal to 0 equals 1. It equals 1. My kids weight, yep. Other kids weight. New. Oh, I should call it num kids. Num kids. Num kids equals self dot num kids. My num kids weight plus other dot num kids times other dot num kids weights. Other num kids weights. My other, yeah. Oh, and then self dot age equals 0. .2. 0.3. 0.2 is fine. Times equals Yes. Nope. Not that. New mute chance equals times random dot uniform plus mute weight. Actually, no. This should be self dot mute chance self dot mute amount. Oh wait, other way. Plus self dot amount, but this has to be minus. I can do math. No, wait, no. This has to be new. I'm dumb. This is new mute chance self dot mute chance. No, self dot mute chance again. New mute amount equals new mute amount times if and random itself. Ripper weight uniform 1 minus self mute amount if random and then new numkids equals new numkids equals int. I know I was confused, but no. We do the same thing, but we make it an integer because these need to be integers. And then we turn creature of new mute chance, new mute amount, new strength, new repper weight, new numkids. Oh wait, no, repper weight is whatever. Why is repper weight? Oh, it is. Wait, never mind. I'm an idiot. There you go. There's your int. Plus self.mute amount. Yes, should be right. Def reproduce self other creature. Self dot numkids plus other dot numkids divided by 2 int. We just need to hard cap it as an integer. If 2 0 self dot reproduce 1 other else this kids dot append yes, yes, and then we just self dot age plus equals 1 other dot age plus equals 1 turn kids. Hopefully the logic makes sense, but basically we're gonna, because this is a very complex simulation of everything, we're just gonna start really simple with just some numbers. You have the mutation chance, mutation amount, strength, which will define how much food it gets. Right, higher strength, you have a higher weight, a higher chance of getting the food. Repro weight, which is basically how much, or it affects how much the creature is represented in the offspring. If you have like a really high repro rate, then you get represented a lot. And if you don't, then you don't. And then kids is how many kids. And then we calculate a food requirement based on 2, which is, we'll just make that a constant. Base food rec equals 2. But yeah, so we calculate it based on whatever number that we want, a random value, and then strength. Higher strength, more food. Lower strength, less food. And then we create an age, because up here we have an age factor, which I think I'm going to use to say that basically like every cycle, there's a chance that like every creature in the population has a chance to die, and the higher your age, so age times this factor gets you the chance to die. So if you're 0, you have no chance to die. If you are 20, you have a very high chance to die. Or you're almost like guaranteed to. If the creature is 5 years old, it's guaranteed to die, because that's when the chance will be 1, and random will be less than 1. And then so age factor is 1, base food equals, I don't know, 100. Plane crashing down around town. I'm searching for a lost and found. In there. Oh wait, then we need to make self dot food equals 0. Def feed self dot food plus equals 1. Def reset food self dot food equals 0. Def enough food self dot food divided by food. You were the one for me. That's why I gave you everything. How you crossed by the stormy sea. Oh, you went to run from me. And then yeah, so we add our food with the other food. Self other plus other dot food. And then if, for example, if the average is we've had double the food, then the requirement, then it's double the kids on average. Where's our int one? Times random dot uniform 0.71. One minus kids lower 0.7 kids upper bound 1.3. Kids chance 0.3. Kids chance 1 plus kids chance. And that's just more randomness. Give you everything. Meant the world to me. I think most of the randomness we have in here is like either like the exact same, so random.random here, but also it's random.random here. We'll use uniform. Why not? Kids chance. Repper chance is also 0.3. So these are a bunch of things we can modify later if we want to. 1 minus repper chance, 1 plus repper chance. And then we just copy this. Alright, so this is random, which is fine. Because this is like the entire random spectrum. This, I mean, we can make this high or low depending on what we want. And then base food rec chance equals 0.2. So random dot, because I like food rec chance. The idea that like there's a bunch of like environmental stuff. Like a lot of this stuff has to do with just the environment and optimizing for the environment. So I'm trying to add as much environment stuff as possible. And I think that is it. If main, then what do we do? So we have our list of creatures. Up equals creature for in range. 100 is fine. Yeah, 1,000 is a little much. Let's start with 20. Range. Actually, we can make we can control the age from here. Dev age self dot age plus equals 1. Age up. Age up, yes. So for this. Okay, so maybe we do base food is 500. Food equals. Okay. Let's say, what is it? Mutation chance. We're gonna use. No, we actually aren't. Because Pandas requires it to be a square. This isn't going to be a square because there's going to be more population. Chances equals this. Mute amount equals this. Strength equals this. Repper weights and num kids. C in population. Mute amounts. Append C dot mute amount. Strengths equals strengths dot append C dot strength. Wrapper weights dot append C dot wrapper weight for C in population. No. Them kids is equals. Okay, we'll do it like this. Nums kids. There. Happy. That doesn't even exist now. Append C dot num kids for C in population. I mean, we do 100 generations for now. We'll start with 100 generations. So this is our log. So then this we can process later when we want to just kind of look at the data. Yeah, so we'll take all of this, we'll add all of that data, and then we'll actually move on to the cycle. So the cycle will be food equals food chance equals 0.2. Actually, let's, I don't know, let's maybe do like 500 is okay. Base food dot uniform 1 minus food chance 1 plus food chance. F in food in range food. Choices lets you add weights, right? Yes. Weights. Equals strengths of -1. K equals food. For choice and choices dot feed. Foods that append food. Choice dot feed, and then actually, how long does this take? Rent. Hi. Oh, okay, that happens like almost instantly. That's perfect then. Population times divided by, I don't know, Yeah, we'll do that. So about 60% of the population will get to mate. And they choose to mate completely randomly. S sorted equals sorted wait population. See that strength reverse is true. Yes, we want high at the top. Temp pop equals CN sort of. Yeah, just do that. Temp pop dot pop I random dot choice as sorted. No. Temp pop. So you just pick a random one. Newgen dot extends. Newgen equals wait, no, just population. Oh, hi, Ghost. Hi again. Sorry. My chat alerts that normally, like, ring in my ear and tell me when chat happened, isn't working anymore. Because, of course, it isn't. So, sorry if I'm a little late to the messages. Pro streamer here. Very, very much pro. Much pro, much streamer. I can if random, not random, is less than see of I wait. If I got enough food. together is at the top. Equals. Oops. Nope. Equals true. Self.foods divided by self.foodrec plus dot food divided by other dot foodrec. Divided by 2. Partner equals together cooperation if this is I enough food. Together of partner, then nation dot remove this. What? Okay, I need to stop just a friends equals s sorted of I. Less than population of I dot How long does this take? Should take. Okay. Partner. Freak show. Freak show. Turn, freak show. What do you mean? Assorted is just population. Like, resorted. And then Tempop is definitely not. Huh? Okay, so. We'll do. ID equals 0. Self dot CID equals creature last ID. Creature last ID plus equals 1. And then we'll use reppers. Def. Population and partner. Repper then? Okay. What do you mean? We found it. It's right there. Current. Creature 0. It's creature. Why is creature? Oh, because it's sorted. We need to make this a new list. That's fine. Maybe that should fix things. Why? How is it not? How is it not in population? I mean, temp equals C in assorted. Is not current. Yeah, we're only at 20. Mm-hmm. 17. Oh, I know why. Okay. Okay. Yeah, I see the problem because I'm removing stuff as the list is being changed. Yeah. Okay, we'll do it a different way. Available. Available equals C in population. Well, unavailable greater than when available. Is twice available choices weights equals C dot strength for C in available K equals 1 of 0. Available dot remove current. Available dot remove partner. Then they do make more. Then we have if cooperation. Then we do all of this stuff. Yes. Okay, yeah, this one we just have to make a to remove list. To remove. To remove was a thing. Oh yeah, I did. I make it. I made it before. To not append. Just I. We don't need to actually put the entire thing there. To remove dot append I. If we don't need to append it twice. Fine to remove. Yeah, okay, wait, no, yes. Yeah, no, we're not deleting the function call. Right? It's pop. Remove and return the item. It should just be automatically deleted because there is no other reference to it. Okay, never mind. Yeah. That's much smarter. Population of I. For C in to remove. Remove C. Are we happy now? Oh my god. Chill. I'm gonna remove this. Print, then population. Hey, okay, so it does stabilize. Okay, cool. Now we have a whole bunch of data. Pops equals populations. This populations dot append population. No, dot append len population. And then we print population complete at the end. But before we do that, if not was dot path dot is dir results. Yes, I know. Import OS. Oh, make. Right, it's make dirs. Right, this should just make a results. Yeah, it should. It does all of it, and it doesn't raise an error even though like the original directory is not there. Perfect. Equals results. Slash results. I equals 1. Well, os dot path results. What? G equals results like that. I should use matplotlib. Matplotlib.pyplot as plt. Figure. Dot. I don't know how to actually use the subclass. Oh, hi, Rosie. How's it going? Do I actually use it? Matplotlib pyplot. Just came by to say hi. Thank you. I appreciate that. Figure. If you're playing to London, right now going for passport checkup. Seeing what I'm cooking? Yeah, so we're making a simulation. And because I got kind of stuck, or not stuck, more lost on my complex evolution simulator, we made a smaller one. And now I'm just trying to figure. Oh, what? Now I'm just trying to figure out how to actually plot it. Oh, we do it like that. Okay. Figure. You got lost in the sauce? I did kind of. Don't get lost in the lamb sauce. This one. Fig size. I think 8.6 is a pretty good dimension size. Right? Yeah, 8.6. Here. Right. How do I do that? It's fig size, yes. Fig size. Fig size. Nope. Fig size equals. Actually, I might as well do 1010. Big fig. Thank you for redeeming your daily cast. You got a common bitefish. And yeah, don't worry about the welcome aboard the ship thing. That's also broken, but so is like everything else. Yep, simple fish. Simple fish. We plot. What? Wait, 149? 1. So the first figure is 1. One, two, 3. I don't. Oh. Wait, what? 1, 1, 4, 9. Oh, it's the X and then Y. Oh, I get it. Okay. How do you label the axes on a figure? Set axes. Okay, I mean that's. What do you got? Okay, customized, and then PLT label, Y label. Okay, so PLT dot title duration. Awesome. No, actually, we'll just do population like this. Population T dot X label generation PLT dot Y label relation count F. And then what else do we got? We got do we show the grid? Yeah, might as well. Customize figure size. That's fine. And then we just plot it. And then we can use multiple. PLT dot plot. Yeah, no, that's fine. T dot plot list rangeland population. PLT dot save fig. Join path. Population. Oh, wait, what? Oh, populations. A superhero. Rent. Then. doesn't like it if you do it the other way. OS dot delete. I know that, but then how did... Greater than one. We need at least two things. Okay. That is a population graph. Okay, and then wait. PLT dot. What are we showing? Show dot grid. Yes, grid. Dot grid. Okay, that's a little bit more helpful. Perfect. Now we delete these. PLT dot title. Chance graph t dot x label generation chance plt dot grid true plt dot plot. Let's see. T dot pyplot. Right. I forgot. Okay, so we're just gonna do up to here. Matplot lib pyplot. How do you get, what's it called? Scatter. I'm pretty sure the method is just scatter. Scatter. points. Located on the roof of myself. For high in range Len chances. For mutes chances of I. Points split. Mute. Hence. Fences. Points. Or points. Points dot extend points. Mute chances points. Some points of mute chances points split of I. M, then M, or M, chances points split point. That list range range, land mute chances, mute chance averages. Oh my god. That might not be very useful. Wait, yes, let's do that. Let's see the figure. To that X label generation mutation chance. Strengths, points, split equals IM for M and strengths of I for I and range and strengths. Strengths points for points in split. Strength points dot extend. Then we plotted it and then we never saved it. Chances scatter. OT dot save fig mute chances trend. PLT dot figure. Then PLT generation. Strength, PLT grid true. Then we do this. Dot scatter. Sub-0 or S in strengths points. S of 1 for S in strength points. PLT dot save figure point of 1 for point in S, then S for S in strength points split. PLT figure size, strength trend graph, generation, strength, PLT grids, list, range, len, strength averages, PLT figure. Okay, now we write all of the results. View chances scatter means literally nothing. Okay, so the average started at about 0.5 and then it trended downwards. You can't see that on the scatter because it's literally everywhere. Maybe we sample the scatter. It's less than 0.0. And then finally, our last set of constants, which is mute chance sample rate equals 0.02. We use 0.02 is a pretty good measure. Add break in a minute-ish. It's never on time, but about a minute. Oh no, len mute chances of I. Oh, yeah, look, that's so much better. You get about 30. You can probably even go even lower. It's not a sample num, it's a sample, it's not a sample rate. Mute chances sample size equals this. And we'll do the same thing for strength, because I'm very sure that strength also suffers the same thing. I mean, not as much, actually. Okay. Well, that's interesting. A population, yeah, the strength trend is just... Probably because it's such a bad... It takes so much food to do the strength. Food rec chance. Food rec strength and 1.1. think we'll do this. This is how we get like food, rec, strength, info. It's like that. I'll try that. Anyways, that's just something, but we are still going to have to do this. So I think even like just, I think 30 is, I think 25 would be fine though. Cause like strength, sample size equals, let me start with 25 too. And then we'll, if, what is it, if random is less than strength sample size divided by len strengths of I. Does that become easier to read? It should. Oh, interesting. It's a lot more volatile. And you can see a lot less of that decrease. This is a very sharp decrease. And this trend is also very, very sharp. Rename results. And then we go to main and say, yeah. Go. Oh, interesting. So this one, the mutation chances have just kind of fluctuated a bunch. Strength scatter. It still goes down, but it's a lot less precise. Well, and then people change, but not as. That's why. Actually, why do we lock it to int? Just leave it alone. It's just, it's allowed to be bigger than 1, so this is okay. Huh. Feels like that population stayed a lot lower. Interesting. Close all of these. Strength scatters much. this strength scatter? Yeah, it is. Okay. Oh, interesting. That one, that definitely went up. Not by a lot, but it definitely went up overall. I wonder if we make all of the chances like 0, so everything is deterministic. I wonder what would happen. Probably need a little bit more time, like a couple more like generations. Maybe not like a couple, maybe like 1,000 or something generations total. Maybe like an initial starting population of like 100, and then. But right now we're just working on dumping all the data. What's next? We did strength. We got. Oh, I forgot to do mute mounts. Mute mounts. Points. Splits equals. I am for m in mute amounts of I if random dot random is less than mute amounts sample size then maybe we do 40. Amounts, points, 4 points, points extend, points, yes. And then PLT dot figure fixed size 1010. PLT title mutation amount. Nope, this is scatter. Scatter plot. PLT dot X label generation, Y label mutation amount. Grid true. PLT dot scatter m of 0, not that, m of 0 for m in mute chances points. Oops, why did I do mute chances? It's mute amounts. Amounts, points. Amounts, points. M1 for m in mute amount points. Yes, and then PLT sayfig amounts scatter PNG, and then we do mute amounts averages equals some point of 1 for point in m ways to get away, to see you again, see you again, some kind of way See you again. See you again. Again. Dum 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 again. Fix this 1010, yeah. Mutation amount. Yeah, trend graph. Generation. Mutation amount. True. List range len. Amounts averages. Amounts. Averages. Yes. And then amounts trend. Okay, next. To get away. See you again. See you again. In kind of ways to get away. See you again. See you again. Repper weights. Weights. Points. Split. Point split. Because it's equals this I am. Why do MSS and strengths? I R or R in proper weights of I if random dot random is less than wrapper weight sample size divided by len wrapper weights of I. Yes. For weights points, for points in the split, we just extend it by the points. And then it's PLT figure 10, representation weight, scatter plot, generation, representation weight, true, PLT dot scatter, R of 0, or R in, no, for R in repper weights points, R of 1 for R in repper weight points. PLT.savefig, repper weights scatter. Yep. And then we just calculate the averages. Repper weights averages equals sum point of 1 for point in R divided by len R for R in repper weights points split. Yes. Then we have figure size, and we have representation weights trend graph, generation true, list range len, averages, yes. Savefig repper weights trend. And then what's next? We have the numkids. Wait, no, not repper weights. Nums kids points split lit equals I k for k in nums kids of I if random dot random less than nums kids sample size divided by len nums kids of I oh wait, no. This is like this. So then there's one at the end that's like here. For I in range len nums kids. Nums kids of points equals lt dot figure fig size 1010 number of kids scatter plot generation number of kids true not a plot. This is plt dot scatter. This is scatter data. K of 0 for k in nums kids points k of 1 for k in nums kids points. ML shit? No. We're doing simulation. Basic simulation right now, but simulation, yeah. Where weights points. I can see why it would look like ML shit, but no. Save fig last dot. Yeah, Happy New Year. How are you, dog? Is it cool if I just call you dog? Or you prefer something else? Path.join. Nums-kids scatter. Yes. And nums-kids marriages equals some point 1 4. Yeah, that's your name. Okay. This is K. For K in nums-kids point split. Big size 10, or number of kids trend graph, generation, number of kids, true, list range len, nums kids averages, yes. Then save OS like that. Yes. Yes. I need to do this. All the way at the top. Equals 40. what? No, I need to look here. Foods. Foods is just one. Alright, no. PLT dot figure face size. PLT dot title. Foods. Foods graph. Full generation. Foods. PLT grid true. Yeah, list range len foods. Foods. PLT safefig foods dot png. Yeah, foods, because I named this one just population.png. Is there anything else I kept track of? I don't think so. That looks like everything. No, this should go at the top. Right, the simulation is complete all the way up here. Simulation complete. Print. Data saved. And I'll save a bunch of metadata, but first I just need to make sure that this works. Yes. Okay. Yeah. Foods was completely random. Amounts scatter.png. Uh-huh. Huh, okay. Chances, that just went down. Okay. Yeah. I had to make the trend also, anytime there's a trend, it needs to have the same, like, scaling as this one, because this one's from 0 to 1. This one's from 0 to 1, and the trend's just so different in scaling. Interesting. Okay, so it went up. Scatter. Okay. That was very volatile. It went up slightly. And then this one, it went up. Okay. How do you get this scaling? Get scaling. Get and set. And set scaling. Yeah, but I want to set the actual, like, number scaling. There it is. So I set xlim and ylim, I assume. I assume you just it's just numbers, right? Okay. Because I know the x-axis is fine. It's the y-axis that is not. Okay, so get current axis is set xlim. I guess the axes are kind of known. Okay, let's go here. Population graph. I guess there isn't really anything to do there because there's only one graph. It's these ones, yeah. So dot xlim how like set xlim. Well, this is or not xlim, ylim. It is yes bottom top. So 0, 1. And then mount is also figure capped at 1, right? 0, 1. Mount is 1. Strength is okay. Max strength. Max strength. Max repper weight. Max repper weight. Max kids. This one is max kit. Is there anything else we want to track? This is for the simulation. Total gens equals 100. We'll just this number and put it in a different place. Results of 1. This population went up kind of, but not like by that much. There we go. Went up. Yeah, population skyrocketed. Okay, yeah. It's not divided by 2. It's times like 0.75. Do we still get the same skyrocket? Almost. Not like the same skyrocket, but it's higher than it was before. Interesting. And then after all of this, open path join d data I'm just gonna bring that all down here so I can see it when this is all the metadata. And we're just gonna, or not, I don't know if I would call it metadata. It's all the sim data. So random takes a seed, right? Wait, do I set, is it random.seed? Yeah, that. Seed. Strength, max strength, max repper weight, and max kids. Base, food, rec, food, rec, strength, inf, food rec chance, kids chance, repper chance. Food chance, age factor, cooperation, total gems, sample size. Repper weight, sample size, numkid, sample size. Some data. JSON.dump some data f. I need to import JSON. Yes, I know. Equals relation. How do you make your object serialize? Make it so it can be JSON-ified. Need that, we don't need that. Need that. Okay, so I do Oh. Like that. No. CID, what else do we need? We want mute chance, mute amount, mute strength. Just all of the data. I could probably shorthand it with the dict, with the dictionary, but nah, we'll do it manually. It's fine. Chance, amount. So you have ID, chance, amount, strength, repper, weight, num kids. Strength, C dot, strength, repper, weight, repper, weight, C dot, num kids. Dict self, return, CID, yes. Good amount, strength, repper, weight, num kids. Yeah, sure. Food rec. Oh, wait. Reset food. That should happen at the top. I forgot to do that. We'll see how much of a difference that makes. But yeah, we do want to dump it all at the end. Food requirements. Is it age, self.age. Anything else? Nope. That one, that's good. To dict. There we go. Other one. Total features ever. Dot last ID minus 1. Last ID. And then the actual data is just everything else. Populate. Populations. And then that's, I think, all the data. f json.dump data. Nope. So it's os.path.join b and data.json, and this is an X. Okay, last one. Reset food. Okay, next. Oh. See, that changes some things. Oh, I should also probably do it with the indent. Indent equals 4. Same thing at the end. Data, much easier. There's only a couple hundred of these. Jesus. Okay. You scroll. Total creatures ever is 6,000 only. Okay. Well, we did it. We made the simple simulation. It's all contained in one file. Only like a couple hundred lines. Took what? 4 hours? Jesus. Okay. Well, that is one simulation. I'm gonna see if I can go over it like step by step what happens as we go through the generations. So we start here. That's just so I can see on the surface how many things there are in each generation. Then we have populations.append, len population. Right, this is all logging stuff. We say, hey, I want to just keep track of all this information. So we keep track of it for every generation. Then for each creature in the population, we reset its food, because we keep track of the food by like adding up a counter, right? So we keep track of the food and make sure that we keep track of the food and make sure that so that we can like add one food at a time and it still works. Sorry, I need more caffeine. And so after like each generation we have to reset the food so that everybody who did have food now no longer has food. Then we generate a new batch of food, which is we take our base food and we generate a random number between, like if this is 0.2, between 0.8 and 1.2, and we multiply it by our base food. So we have that many food, and we also want to keep track of that just for like the context for things that happen. Then what it does is that we generate, or we pick from the population randomly based on the strengths. So basically, the stronger a creature is, the more likely it is to get fed. And then we feed it. And then we do that for the number of foods that there is. So we distribute all the food, and then we say, great. Now we need to make a new generation. So the available population right now is all of the population. Then we say, all right, our new generation is empty so far. And while the available population for mating is greater than 10% of the total population, and the population and the available population is greater than 1, just as like a failsafe. If the population is too small, sometimes 10% is less than 1. And obviously you can't do very much if there's 0 people left. So we need to make sure that there's at least 2 people, or 2 creatures to breed. Then we have, what do we do? Right, because we're using a weighting system, we pick randomly from the available population using the weights. Using the strength. So the stronger a creature is, the more likely it is to mate first. I don't know, maybe this needs to be like 0.3 or something. We'll see what happens. Then we say, it says choices because that's the only way to use the weights. But because we only want 1, we say, hey, we want 1. And then we pick that item. And then we say, well, I mean, we've chosen it now. It's removed from the available pool. Then we pick a partner randomly. And we remove it from the available pool. And then we call the reproduce function. What does that do? Basically, it figures out how many kids that they're going to have. And for each of those, it makes a kid. It does this because I don't want to use like averages and stuff for mutation chance. So 50% of the time it's going to use the current creature's mutation chance, and 50% of the time it's going to use the other creatures. Right? Bunch of kids. We return the kids. They go back to, now we go back to here. Where's it? Here. Let me say, alright, all of those kids, add them to our next generation. And then we check something. If cooperation is on, then the couple is going to share their food. So we check if together they have enough food for both of them. Oh, I'm an idiot. That's probably not helping. We check if together they have enough food, and if they don't have enough food, we remove them. That's what it's supposed to do. I think that's what it does now, right? That is what this does. Yes. Okay. If we don't, then they say, well, they're not part of the population anymore. Because we don't, they died. Then, because of how the language works, we create a list of creatures to remove from the population. Then we tell each member of the population to age up 1 year. And then, if not cooperation, basically if they weren't cooperating and sharing food, then we need to check if individually each creature has enough food to sustain itself, and if they don't, then we add them to the list of creatures to remove, and then we generate a number, basically to see, do they die of old age? If they do, then we also add them to the list of creatures to remove. Then we remove all the creatures in that list, and we extend the population by the new generation. We add all of the creatures in the new generation to the population. Then after the simulation is complete, we dump all the data, and then we plot some of the data to make it easier to read, and then we dump all of the constants that we used. Okay, 23, 230, right? Should be exactly the same every time because we're using the same seed every time. Population. Oh, that's spiky. Okay. Well, that's what the simulation does. Hopefully that made sense. If you have any questions, feel free to ask. Yeah, I don't really want to work on that right now. So we're gonna play a game. Well, I'll wait for everyone to come back from ads. Ads are over, hopefully. Almost? Maybe? Alright, let me check. Never mind. Minute left. I'm an idiot. Welcome back from ads, everyone. Thank you for sticking through the ads. I really appreciate it and help support the channel. All money that comes from ads, subs, all that stuff goes right back into the channel and making it better. Cool. With that, it is late. I already started stream way later than normal, and I've already been streaming for, even though I've only been streaming for 5 hours, I normally try to hit 6-ish. But yeah, I'm probably gonna end it here. So let me go find someone to raid. Okay, yeah, that's to be expected. Sure, why not? There's the raid message if you are subscribed, and there's the raid message if you aren't. First one should look like that. Alright, thank you all so much for watching. Again, I appreciate it. Take care of yourselves. Dying is in fact bad for your health. Get good sleep. Do as I say and not as I do. Drink water. Eat food. And I will see y'all next time. Bye.